Okay, so this one we're going to be solving linear inequalities with two linear inequalities, and we're going to find the solution. So we're going to see if certain solutions are going to work for certain linear inequalities. So it's going to be made up of two or more inequality equations. A solution is going to be an ordered pair that makes them both true. Okay, so let's try graphing this one first. So let's graph this top one. Start at -3. Going to go up 2 to the right one, up 2 to the right one, up 2 to the right one. Keep it going. Down 2 to the left one, down 2 to the left one, down 2 to the left one. Okay, it's a dashed line because there's not a line underneath. Okay, pick 0, 0, see what side we shade. 2 times 0 is 0. 0 minus 3 is -3. Is that true? Is 0 less than -3? No, it's not. So we got a shade on this right side here. Now I'm going to pick a different color to do this other graph. Well, we have to get y by itself to be able to graph it, so let's subtract 2x from both sides. So now we're going to start at 2. We're going to go down 2 to the right one, 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 up 2 to the left one, up 2 to the left one. Okay, it looks like this one's also going to be a dashed line because there's not a line underneath of my inequality. Plug in 0, 0. -2 times 0 is 0. So is 0 greater than 2? No, it's not. So I need a shade on top of my pink line. On top of my pink line. Okay, so that means the area that they share is our answer. All of this that I'm highlighting in red here. So that means if I picked any of these points in my red, that means if I plugged them into both equations, they will be true. So we're trying to find that double shaded region, a point that sits in both of those equations. It's an all or nothing deal. They both have to be right for it to be true. So let's try one. So we got 212. Let's do this equation first. So 12 is greater than 2 times 2 plus 4. 2 times 2 is 4. 4 plus 4 is 8. Is 12 greater than 8? Yes, it is. Now we've got to check our second equation. Okay, 3 times 2 is 6. 6 plus 7 is 13. Is 13 greater than 12? Yes, it is. So is it a solution? Yes. Make sure you tell me if it's a solution or not. Don't tell me if it works and if this one works and this one doesn't work, or this one works and this works. I need to know if it is a solution or not. Okay, is this point a solution? So let's put it into this first one. So 3 times 8 minus 2 times 2. 3 times 8 is 24. 2 times 2 is 4. 24 minus 4 is 20. Is 20 less than or equal to 17? No. It has to be true for both to be a solution. So I automatically know it's not a solution. So tell me that. I don't even have to try the other one because if it has to be true for both. So if I find out one of them's no, I know that it's not a solution. Okay? So, solve by graphing. Okay, so this first one here, we start at 4. Then we go down 2 to the left one, down 2 to the left one, down 2 to the left one, oops, down 2 to the left one. Okay, it's a dashed line because there's no line underneath my inequality. Okay, let's figure out what side to shade. Plug in 0, 0. 2 times 0 is 0. 0 plus 4 is 4. Is 0 less than 4? Yes, it is. So we shade on my 0, 0 side. Let's pick a different color from my other one so I can tell the difference. Okay, for us to be able to graph it, it has to be in y equals mx plus b form. So let's get y by itself. Get rid of the things not attached to y first. Okay, y is still not by itself. We got to divide everything by -1, which will flip my sign. Don't forget, multiply or divide by negative, flip your sign. So I'd get 2x minus 4. So I'm going to start at negative 4. I'm going to go up 2 to the right one, up 2 to the right one, up 2 to the right one. Okay, or I'll go down 2 to the left one. Okay, it's going to be a solid line. Let's plug in 0, 0. 2 times 0 is 0. 0 minus 4 is negative 4. Is 0 greater than or equal to negative 4? Yes, it is. So I can shade on the whole left side of my blue. So that means what they share is this center region here, what I'm shading right now. They share that. So all of those points will be true if I plug them into both of my equations. Okay, let's try this one first. So let's make this a 5. Okay, so then I'm going to subtract 5x first. Then I'm going to divide everything by negative 5. I divided by negative, so I flip my sign. 15 divided by negative 5 should be negative 3, so we're going to start at negative 3, up 1 over 1. Or down 1 to the left 1. Okay, it's going to be a dashed line. Let's plug in 0, 0. 0 minus 3 is negative 3. Is 0 greater than negative 3? Yes, it is. So we're going to shade everything to the left. Now we got to do our other one. So we got to subtract x from both sides. And this 7 I'm going to make an 8. So I'm going to get 2y is greater than or equal to negative x plus 8. Divide everything by 2. Don't flip my sign because I didn't divide by negative, so I'm going to get negative x over 2 plus 4. So we're going to start at 4. I'm going to go down 1 to the right 2, 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 or up 1 to the left 2. Okay, this is going to be a solid line this time because the line is underneath my inequality. Let's plug in 0, 0. 0 divided by any number should be 0. So is 0 greater than or equal to 4? Well, no, it's not. So I got to shade above my pink line. So that means this is my double shaded area right here. So that means all of those points, if I plugged them into both of these equations, it should be true.